Kenny, could you kindly help me resend the link? Please confirm you can hear me. Anybody around? Can we hear me? Can anybody hear me at all? Oh, I hope we have not I've not started again with network tonight. Oh yeah. Okay. Okay. Somebody said yes. We can hear me, right? So I'm not just talking on top of my head. All right. Okay. Okay. Cool. 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 So let's get started. I'm just going to quickly run through what we did yesterday. I'm not sure I quite finished, right? And what I'm just going to do quickly is to emphasize on the two formulas I gave us, which are the Ohm's law formula and the power formula, right? So the Ohm's law formula, which is V equals to IR, and the power formula, which is P equals to IV, right? A very essential formula that we don't want to forget. I expect that by now we should have those two formulas in our head already. Okay, so and I did say that from the Ohm's law or Ohm's formula, excuse me, you could calculate the voltage, right, that is supplied to a circuit. You can also know the current that is flowing through the circuit. The same way you can know the amount of resistance that is available in the circuit, right? And yesterday, just a little bit of recap. Yesterday we talked about electricity in general, how that similar the voltage, the current, resistance to, for instance, the voltage is similar to the water tank, right? A tank where you have water inside, and we said the current is similar to the flow rate of the water inside the tank through the pipe, right? So then you have water flowing through a pipe, all right? Current is similar to that, right? Literally, that water is not the current, but the flow rate, the rate at which the current flows, right? The rate at which the current flows is what we analogous, give analogy to current, all right? In an electric circuit, current flows through the circuit. Current is not literally voltage, all right? Current is not literally voltage, but current flows through the circuit, okay? The same way water flows through a pipe, okay? Now you have the valve, all right? The valve that you turn. And what do you do with the valve? You try to shut the water or um, allow the water to flow. That's what you do with the valve, all right? So that is analogous to the resistance, all right? The more you open the valve, all right, the more water you are allowing to flow, which is analogous to the fact that the lesser the resistance that you present to a circuit, the higher the current that will flow, all right? So if you open the valve completely, for instance, you're giving the flow of water less resistance, right? Compared to when you just shut the valve. When you shut the valve, you're giving the water, you're blocking completely the water, you're blocking it from flowing, right? So that way you've shut the valve and you have just increased the resistance that you have given to the water. All right. So that time water will not flow. All right. So also if you increase the resistance that you give to current to a certain amount, you find out that no current will flow through the circuit again. So that's just kind of like the way it works. All right. I hope that makes sense. Okay. So and yeah, resistance is simply the opposition that you give to the flow of current. Right. So the opposition you give to the flow of current is the resistance. Anything that opposes the flow of current in a circuit is called resistance, right? Now, there are some other components, but we don't need that, in this course, right? But primarily or fundamentally, anything that opposes the flow of current is what resistance, right? And when you're doing your solar design and all of this, you have to put into consideration a lot of things, right? So, but we're going to get to see all of that as we go through the course, right? So, let me just quickly share this whiteboard, and it's just a little bit of recap, and we'll move quickly to what we have to do. Please confirm my screen is visible in the whiteboard I'm sharing. Confirm whiteboard I'm sharing is visible already. Can we confirm it already? Is it visible? All right, cool. Yeah. So I have right here two formulas, right? Um, we have the P, which represent the power, all right, equals to current multiplied by what? The voltage, right? So here you have the current, right? And here you have what? The voltage. You have the voltage. Here you also have the current, and then here is what? The resistance. So now I said these two formulas very fundamental, and we have to take note of them. I'm emphasizing on it because they are very important. Yesterday I said that for you to know the power of any device or any machine, right, or any component, for you to know the power, you only have to get the current rating of that device and then the voltage. You're going to see a white label, right? Or sometimes it might not be a white label, it might just be written engraved into on the back of the TV, right? But most of the time a white label. So when you check the white label, you're going to see some ratings at the back, right? You could see voltage rating, you could see current rating, you could see, and if you don't see the power consumption, you're going to see the voltage rating and the power and the current rating. So they expect you to use the voltage to multiply the current for you to get the power consumption of that TV. What that means is that whenever you that TV to power, right, that TV is going to consume some amount of power. It's going to draw some amount of power from the source. All right. So how you know the amount of power that the TV is going to draw is by multiplying that voltage that is written on it by the current that is written on it. That will give you the power. And that is in the case where the power is not written at the back of the TV. All right. For most ones, you're going to see the power rating. They will write maybe 70 watts, 100 watts, and so on. They're telling you that this TV, whenever you plug it, is going to draw 70 watt of power from your source, right? From your meter. And so, but after 1 hour, you'll find out that your meter has read that 70 watt of power has left it. All right. So if, say it's just your TV that is on, nothing else is on. All right. So at the end of 1 hour, and you go to your meter to check how much of power you have consumed, you're going to see that you have actually consumed 70 watts under 1 hour. Right. Yeah. Can we hear me now? Am I audible now? Hello, can we hear me now? Okay, okay, good. Thank you. Thank you. All right. So I was saying that the 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 your charger is rating 5 volts, 2.4 amps, for instance. All right. By the time you multiply 5 times 2.4, you're going to get around 10 point, 12 point, what did I get there? You're going to get 12 volts. All right. That's simply, 12 watts. That simply tells you that your charger can give you 12 watts of power every hour, every 1 hour. Right? Every 1 hour, your charger can deliver to you 12 watts. That's what it means. All right. So when next you're going to buy a charger in the market, you know, look at the output rating. Some of you still buy 1 amp charger. You're not going to be complaining that the charger does not is not fast. This charger is not fast. So you have to check the output power or output rating of that charger. All right. You have to ensure that is enough for your to charge your phone. All right. So let's say, for instance, your phone is um, your phone is 5,000 mAh. All right, battery. All right. 5,000 mAh is the same thing as 5A. All right. By the time you multiply it by 1,000, you're going to. Yeah, I explained that in the video I sent you, so we should should sort of understand that right now. So 5AH, all right, times your battery is usually 3.7 volts. So your phone, all right, an average phone is around, an average power of, what am I saying? The power of an average battery, all right, used in most of the phones is around 18 watts. Okay, so now your 18 watts needs some amount of at least for you to charge your phone under 2 hours, right? That 18-watt battery needs around 9 watts of charger. So it needs a charger that can consistently deliver 9 watts of power to it. All right. So if you have a charger that delivers 9 watts, okay, so under 2 hours, your phone should be full. Filled. Right? It should be filled. So the example I was using the other time, if you go to buy a charger that has is rated 5 volts, 2.4 amps, all right, that will give you 12 watts um, under 1 hour. So if you plug that kind of charger to your phone, you are going to see fast charging, right? Because that charger is actually delivering maximum power to your phone, right? That's why you'll see fast charging. But if you go to buy a charger that is just 5 volts 1 amps and you plug it to your phone, the way your charging will be crawling, you say if you go tire. All right. So that's just to make us understand what power is. So you have the power input, you have the power output. All right. For your charger takes in power from the source and delivers it to your phone. For the inverter, for instance, the inverter also takes power from the battery and delivers it to your appliances. All right. The inverter takes power from the battery and delivers it to your appliances. All right. So your battery takes power from the solar panel to get charged. All right. Your battery takes power from the solar panel to what? To get charged and delivers that power to the inverter. The inverter delivers the power to your load. I hope that makes sense. Let me know if you're following. All right. So let me just share my screen and we can start what we have to do today. This our daily 1 hour is really some in but we'll try. We'll try. We'll try. Slide is. All right. So today we're going to be dealing with PV components. All right. We're going to be dealing with PV systems. That's basically what we're doing. Yeah. I don't know how fast we move. All right. Please confirm I'm still audible. Are you guys still following? Just type following if you can. If you are still following, please, so that I'm not just talking over my head here. Just type following if you're still following. All right. Yeah. Thank you guys. Thank you guys. Okay. So while my presentation is loading, I'll just so we have quite some major components of the PV systems, right? And the first one is the solar panel, which is the PV modules, right? Photovoltaic modules, right? And um, the ones, some other ones are the the inverter, right? We also have the battery, and we have the charge controller, right? Um, After those four, some other components that we use, for instance, the breakers, the surge protectors, the AVS, all those are just secondary components, right? But the major components are the panels, the inverter, the battery, and the solar charge controller, right? I don't know why this presentation used to take time to do that first. It's fine. Okay, so those are the major PV systems, components that we have, right? And we're going to be learning about them one after the other. So we're going to start with um, the PV, right? I know I talked about the photovoltaic module, which is the solar panel. I think that was our first day. Yeah, that was our first day. First day and all of that. While I was just talking about solar general and all of that. So yeah, we're going to be touching a little bit of that. My slide. I don't know why you wasting time. Go with my slide. Go with my slide. Let's just wait for you to. Usually takes time the first time. I have it. I have it somewhere. Here I'll just display it for. Yeah. Share this. I have it open in another place, so I'll just open it there. I hope we can see it now. And we see that now. I hope you can see my screen. So all right. So yeah, we're going to be starting with the PV, right? That's the solar module. Yeah. So, like I said to us the first day that when you have a square meter space, right, that square meter space is receiving up to 3.16 kilowatt of power, all right, and up to 3.6 kilowatt of power, daily. That's square meter, right? But if you have a solar panel, right, that solar panel, if you have a solar panel of 1 square meter, right, in size, in dimension, right, meter squared, right? What am I even saying? Square meter, meter squared, are the same thing, right? So when you have a solar panel of 1 square meter, right, that solar panel can generate up to 1,000 watt of power for you. So imagine a square meter, right? And that square meter is just solar panel, right? So that solar panel can generate up to 1,000 watts um, um, per meters, 1,000 watt of power, right? Under full sun drive, right? That's going to be the maximum um, output. And like I said, that was yesterday. Was it yesterday? No, it was the first day. That um, high temperature reduces panel efficiency, lowering the panel output. Right. So, and we said that per degree rise in temperature, I think it reduces it to about 0.3 to 0.5%. Right. So with every degree rise in temperature beyond the normal temperature rating, which is around, I think, 35 degrees Celsius or 25 to 35 degrees Celsius, right? Every increase in temperature beyond that reduces the efficiency of the panel by around 0.3% to 0.5%. All right. So literally, you don't really need the sun to be hot, or you don't need the heat from the sun. The heat from the sun reduces the efficiency of the solar panel. Right. So if we can have a system whereby there is sun radiation blasting the solar panel at a very minimal temperature, you are going to get maximum efficiency from the panel at that time. I hope that makes sense. Okay. So another thing you want to understand concerning solar modules is the fact that you don't want to place them in a place where they are shaded. What that means is that you don't want to place them in a place where uh, something is blocking the sun from reaching them. Right? You want to place them in a free, open space. All right, and you also want to you also want to ensure that the sun rises from the actually that's not properly correct. That sun rises from the east to and sets at the west. Holding this now sun rises and sets, we know, right? Not necessarily from the east to the west. Okay, so that's latest development. But of course, when you're mounting a solar panel, you have to check where the sun is rising from, and also ensure that when the sun sets, where you are going to mount your panels has to be where the sun can reach it, whether it's setting or it's rising. I hope that makes sense. So the panel has to be in a position free from any form of barrier, and it's placed in a place where whether the sun is setting or the sun is rising, it consistently have access to direct sunlight. Right? You don't want to have any shading effect on the a barrier for the panel. Okay. So also there is a way you have to worry. How will I say that? There's a way you have to properly place the panel so that it's directly facing the sun. That is the panel orientation. You don't just want to place it where maybe it's now facing down and the sun is now rising from it. It's now facing down. No, you have to face it at an angle enough that that sun is blasting it directly. Right? This is to ensure that you get maximum efficiency from that panel. Right? So also you have to ensure that it's far removed from where there is dirt or debris, right, that blocks sunlight. So one thing with the panel is that whenever you have dirt or debris on the panels, it sort of stops it from producing efficiently. Okay, so what happens is that let's say, for instance, you have a lot of dust on the panel, it's going to really block some of the sunlight that is supposed to be receiving. Right, because now the dirt, right, has covered the surface of the panel, and the sunlight is getting is not really striking the panel properly, unlike when there's no the surface of the panel is free from dirt or debris, and the sun is just blasting it directly. So you have to ensure that the what's it called? The panel is free from every form of dirt or debris. And that's why some people, they get to do maintenance even on their panel. If your panel is in a place where there is a lot of dust, or debris, you have to always do consistent maintenance on it, especially during dry season where there's a lot of dust, in the atmosphere and all of that. You have to consistently check that dust as not covering the solar panel to reduce the efficiency and all of that. So you have to always clean it sometimes if you have to and all of that. Okay. So yeah, you also have to do a proper installation and consistent maintenance. If you have to clean it, all right. If it's in a place where you are not reach, you have to get an expert that will do that for you. So, like I said earlier, in our first class, we have different types of panel. We have the monocrystalline, polycrystalline, we have the thin film panel, and some other innovation in panel now. Of course, there's not so much of to we know already that the monocrystalline panel are the best and the most efficient, around 18 to 23, 23% of efficiency. So yeah, now there are some innovation in solar technology, right? And this is uh, based on your solar panel. Okay, so we have the PERC cells, right? That enhance efficiency by reflecting unused light back into the cells. Now, when the light is um, eating your solar panel, right? There's every tendency that there are some lights that they are just on the surface of the panel. Right? They are not really um, reflecting to cause electrons to move and thereby generating current for you or electricity for you. So PCRC cells, PERC cells, ensure that they reflect back the unused light into the cells, right? Such that the cells have even more light, right, to use, right, in converting to electricity and all of that. We also have bifacial panels. Bifacial panels are panels that have two faces, right? Which means that if you place them like this, if sun is hitting them from here, from this side, right, they are going to generate. Okay. Also, if the sun is hitting them from here, they are going to generate. They literally have solar cells at both ends, right? At both faces. They have solar cells. Unlike your normal regular solar panels that is just one face, right? If the other face is white, kind of. Okay. So, but bifacial panels have two faces, right? They have two solar cells, one at the one end, the other at the other end, and all of that. So we also have half cut. I'm going to show us the picture. We also have half-cut cells. Half-cut is that innovation that allows you to, even if you want to install your panel in a shaded area, let's say you don't have any other choice. That's the only place to do your installation and you don't just have any other choice. Okay. So you could buy an half-cut panel. Half-cut panels mean that you have divided the panel into two sections, right? If So if one side of the panel is shaded, the other side is not shaded, and that other side can keep generating can keep generating electricity for you, right? So that's half cut. Before solar panels used just to be one. You understand? They will just connect all the solar cells in series, one single solar panel, right? But right now, we'll find a way to, yeah, like you can see this one. This is an half cut panel. Right? So you can see that it's divided into two. So if this place is shaded, let's say a barrier is covering this place, inhibiting it from receiving sunlight, this place is going to be working as long as there is sunlight on this area. Before half cut, right, it's just one single solar panel like this. They are joined all the way from up to down, such that if this area is shaded, your panel might not even generate anything because this might be the area that has the highest efficiency in generation, and this place is very low, right? You might not be generating so much, but for the half-cut innovation, even if this place is shaded, this place will still continue to generate power for you, right? So that's the idea. The bifacial, let's see if I can see bifacial. I hope you're following, right? The bifacial has two two faces, all right? So there's a face here, right? These are solar cells underneath, and there is another face that is currently facing the sunlight, right? As you can see here also, this is the back of the panel, and there are solar cells mounted at the back. Right? There are solar cells at the back, which means if the sun is coming, eating it from here, it's going to generate. If the sun is eating it at the outside, it's going to also what? Generate. That's basically what we mean by facial panels, right? So depending on what you're trying to achieve, buy buy what you want, right? Depending on what you are trying to achieve. All right, so talked about all of this already: monoscrystalline, efficiency, the cost, this most expensive, appearance, uniformly black. These are some, these are ways you could identify them. This is blue. All right, this is uniformly black. This has some blue stuff. It doesn't mean that all the blue solar panel are polycrystalline. But if you want to know them, just check the back. There's a label at the back. You're going to see if it's polycrystalline or mono. Thin film are not really so how will I say now? They are not so really available like that. Like they're not common. Who's using flexible solar panel, right? So yeah, under temperature coefficients, under increased temperature, this uses less efficiency than most of these ones. Right? This workspace, right? Space needed, right? This needs least space per square meter. Right? Needs least. You have to, when you're doing your installation, you have to space your panel properly, especially if you stream them. Reason is that so that they can, the radiation can be effective on them. So yeah, some key parameters. Let me see. Some key parameters that you have to understand when we're considering or dealing with. Not sure we're going to finish this particular. It's much, all right? So most likely I'm going to finish tomorrow, okay? So that as from next week, we're going into auditing, which is the main part of design. We're literally going into design as from next week. So I hope we'll finish this one tomorrow because it's a lot. I think my slide is around up to 30 pages or so. All right. Okay. So some of the terms that you have to get yourself familiar with. I hope we're following. Let me still know if I'm audible. We still hear me? Are we following? Are we following? Can we hear me? Makes sense. Are we gaining? Are we learning? Are we learning? All right, let's continue. Let's continue. Let's continue. Let's continue. Let's continue. Let's continue. So yeah, you have the open circuit voltage, right? And this is the maximum voltage. No. We're talking about panel now, right? If you check the back, let me show us. If you check the back of your panel, you're going to see white label at the back. Solar panel label. you're going to see some parameters that are written. You're going to see some terms, and you wonder, what do they mean? What do they mean? What do they mean? Why is it taking time? I've clicked it. So on those labels, right, you're going to see stuff. You're going to see open circuit voltage, which is usually called VOC. You're going to see open circuit voltage, VOC, right? You're going to see what the hell is this? Right, you're going to see the open circuit voltage, right? And this is the maximum voltage when no load is connected, representing the panel top's voltage limit. Now, when you just have your panel and you are not connecting anything to it, you are not connecting it to battery for charging, right? The voltage that it generates at that point, the maximum, is called the VOC, which is the open circuit voltage, right? Open circuit voltage. The voltage you can get when the panel is not connected to anything, right? It's not connected to anything. So depending on the size of your panel, you have different VOC, okay, depending on the size of the panel. This stuff is right. So depending on the size of the panel, you're going to have your VOC. Another thing is what the short circuit current, ISC, right? Which is the maximum current when the terminals are shorted, indicating peak current flow. Now, have you experienced a spark before? Let's say you mistakenly, you mistakenly connect live and neutral wire together, and then you are, bah! Anybody has experienced that before? What is this giving me again? Just need a label. Come on. So, anybody have experienced that before? I mean, you mistakenly just connect uh, live and neutral together, and then, and then before you realize it, the next thing is a spark. I mean, a very loud one for that matter. So, yeah, I've experienced it a lot of time, right? What happened, is the fact that you're trying to cause a large current to flow, right? You just short circuited that path of current. You short circuited the system. That is why you had that spark. Now, you have that spark before because at that moment, large amount of, as a matter of fact, infinite amount of current is trying to flow through that short circuiting system, right? Infinite amount of current, right? That is why you hear that, and then it can even cause fire, right? Because up to 1,000 or 2,000 amps of short circuited that stuff, right? So that is exactly what this is trying to explain to us, that short circuit current. What's this now? That these are the things you are going to share. I just want to show us, how the solar label looks like. I don't know why this. So, but I think we should be able to from here. So this is rated maximum power. Confirm you can we see what is written on the label? Can we see what is written on the label? Then the current at P max, right? Which is that's the max current. And then you're going to see voltage at P max. I'm going to explain what all of those mean. Short circuit current, open circuit voltage, nominal operating temperature, module efficiency. This is 16.7. That's huge, right? And then you have weights of the panel. You have the dimension, you have the maximum system voltage, you have the maximum series of fuse rating, maximum load, and then application, which is class A. Yeah. So that's the short circuit current is the current that flows through the panel when you try to short circuit the terminals. That means you try to connect the positive to the negative. The maximum amount of current that will flow is the short circuit current, right? And that will help you determine the value of fuse that you are going to use for the panel if you have to use fuse, right? Or circuit breaker. Okay. So another thing is the maximum power point. That is the P max, right? The voltage current combination delivering what? Peak output power, which is rated in what? Watt peak. So this is the maximum power that's the panel, right, can deliver to you. Okay, the maximum output power that the panel can deliver to you. You also have the voltage and max power, right? So why the power panel is delivering maximum power to you, the voltage you can get is called the VMP, is the voltage and current, VMP and IMP, which is voltage and current at a max power, right? It defines the operating point for best energy use, right? You also have the fill factor, which measures the square or the squareness. Measures curve squareness, indicating panel quality, as calculated by um, VMP IMP divided by. So this shows you the quality of the panel over time as you begin to use it. All right. So now we have arrays. All right. Those are the arrangements and the connection of panels. Now, panels can be connected in series. Panels can be connected in parallel. You can also decide to connect in series parallel, depending on what you're trying to achieve. Okay. So let's go back to our blackboard. I need to do some bit of explanation here. Drawing. Okay. All right. So I was saying that you could connect your um, panel in series or in parallel, right, depending on what you want to achieve. So now, whenever you connect anything, be it battery, panels, right, or any system in series, whenever you connect, please take notes. Whenever you connect any system in series, be it battery or panels, what you're doing is an attempt to increase the maximum voltage that those panels put together can give you. Whenever you connect system in series, you're trying to increase the voltage, right? So say you have a panel of 50 volts, each of them is 50 volts, and you have two of them. If you decide to connect that panel in series, right, it means that by the time you're done connecting them in series, their output voltage would have increased from 50 volts to 100 volts, because now you're combining 50 volts from one panel, 50 volts from the other panel, and you're connecting them together in series, right? This will give you 100 volts in total. Why is this one taking time? I guess it's my network again. I hope you can hear me. Can you hear me? Just be sure my network. Can we hear me? Please confirm you can hear me, please. Yes. Am I explaining properly? Are we getting it at all? Please let me know. Any part you are not getting, kindly let me know. Aim is so that we get what I'm trying to say, please. Maybe it may explain something again. Let me so, Thank you, Samuel. I appreciate it. Okay, so I was saying that you could connect panels in series and you could connect panels in parallel, depending on what you want to achieve. All right, so let's say what I want to achieve is I want to have increased voltage. Okay, I want the voltage of the two panels combined together to increase. What I have to do is to connect the panels in series. All right, how do I do that? Let's say this is the positive of this panel and this is the negative of it. Also, this is the positive of this panel and this is the negative of it, the negative cable. So panels used to come, let me show us. So this just wipe. Why? They wiped. I have to draw it again. Personally, it's not good. So the network is not okay. Like it's not at its peak. But thank God it's serving us today, at least managing it. So I think I'll have to draw my panel again. Know why that's got cleared. This one is clear too. My panels are disappearing. I hope you can see it. I don't know. That page is it's funny. Trying to show us how the panel cable looks like. So every panel has an output has output terminals and usually attach cables to them. Cables to them. To load this one now. Reloading my whiteboard also. I don't know. YouTube does not have inbuilt whiteboard. So I'm trying to reload this one. Network is slow and sluggish. Slow and sluggish. All right. Can you see this? Can you guys see this cable here? It's supposed to be two, and the other one is going to be at the other side. Right. So these are the cables of the panel. If these cables are usually attached so that you can make it. Yes, there's a whiteboard that doesn't take time to load, but that one used to that one hangs up. It's gonna work. um, trying to explain series and parallel. I want to show us the connection. Uh, that's why I'm taking time like this. All right. So while we wait for our board to load, let's just do something else. So yeah. Um, Okay, so I was trying to explain the series and parallel connection of solar panels. In series connection, voltage acts while current remains the same, right? So let's say you have three panels, each of them is 20 volts, 10 amps rated, right? By the time you connect these three panels together in series, you would have had 60 volts, right? The current remains the same. Why? Because you only connected those panels together in series, right? Whenever you connect panels or battery together in series, you only get to increase their uh, their voltage, and the current rating of those panels remain the same. Unlike the parallel connection, right? When you connect um, panels in parallel, you increase their current and the voltage stays the same. So let's say you have the same three panels rated 20 volts, 10 amps each. By the time you connect those three panels together in parallel, you are going to increase their current, right? So each of their currents adds up. 10 plus 10 plus 10 gives you what? 30 amps, but the voltage stays the same. The voltage takes what? Just one of the, excuse me, takes just one of the voltage. And for the series also, you can see that the voltage is increased, all right? Three panels also, but the current stays the same, right? But you can choose to do a combination of both, where you have series parallel connection, depending on what you're trying to achieve, right? And this is usually because, for instance, if you're using a charge controller that does not allow beyond a certain amount of voltage, right? You can't go. There's a limit to how much of panel you can. Yeah, finally confirm you can hear me, guys. Confirm I'm audible. Hear me? Hear me, guys. Can you hear me? Can I continue? Not audible enough. How about now? How about now? Hope I'm audible enough now. So I'm just going to do the series and parallel work. I'm going to give us assignment also. All right, thank you. Okay, so let me just quickly talk about the series and the parallel connection of the um, solar panel, and then I'll give us an assignment, and we'll call it a night. It's been a nice time already. Okay, so now to connect in series, right? Right, to connect in series, all you have to do is to connect unlike terminals, right? What do I mean by unlike terminals? You have positive terminal here, you have the negative terminal of the panel here. This is panel 1. Let's label this panel 1, and this is panel 2. All right. So what you have to do to connect in series is to take one terminal from the panel 1, take an opposite terminal from panel 2, and connect them together, right? I'll go again. To connect panels, these two panels in series, take one terminal from panel 1 and take an opposite terminal from panel 2 and connect them together. All right. So now I'm going to take this negative terminal from panel 1 and I'm going to connect it to the opposite terminal, which is what? Positive on panel 2. This way, I have connected these panels together in series. Okay, so now let's assume this panel is 50 volts. This is 50 volt also, right? Connecting these two panels together in series will mean that by the time you measure from here to here, you are going to get what? 100 volts. Right? You are going to get 100 volts. Does that make sense? Let's say I have another 50 volt panel. Right? 50 volts. And this is panel 3. This is the positive terminal, negative terminal. All right? So let's say I have another terminal 3. Another panel 3. How will I connect it? Okay. Now I know that the output of these two panels connected together is what? This is the plus and the minus. Such that if I measure from here to here, I'm going to get what? 100 volts. So what I have to do again, since I have connected these two panels together in series, they have become a single panel with two terminal outputs, 1 and 2. Initially, we have 4 terminals. We have 1, 2, 3, and 4. Right? We have 4 terminals. Now, I only have 2 terminals because I have connected these 2 together already. So they are out of it. They are not part of the output terminal again. And I'm now left with what? The plus here and the minus here. Because I just connected the minus here to the plus here. So I'm left with what? The plus here and the minus here. So this is looking like just a single panel now. Right? Just like you have here. Plus here, minus here. Right? So in order for me to connect these panels that I've connected together to this one, right? I just have to take one terminal from this panel, connect it to an opposite what? Terminal. Hello guys. Oh my god. Can you hear me now? Oh my god. Oh, I don't know. Yeah, thank you. My board has disappeared also. It's going to take a lot. See what we're going to do. I think we might have to continue from here. So I don't know what we're going to do. I don't think we can continue. So I don't know.